Okay, here I'm going to solve this problem here, number 3. We've got functions, we've got 8 different f functions, 8 different g functions, and 18 different h functions. And here f is mapping the set R to the set S, g maps S to t, and h maps t to R. Okay, and so part A says write down the sets S, T, and R. Assume all elements of each set appear in the above tables. Okay, and so what we've got is the set R has to be here because that's the domain of the f functions. Okay, so that's the set R. The set S is the range of f, and the range of f is mapping sets elements A, B, and C to numbers 1 and 2. So S is the set 1 and 2. And it's possible that the set S would have more than just 1 and 2 in it, and that none of these functions f would be onto. In other words, none of them would contain all the elements of the range. But it says here that all elements of each set appear in the above table. So the set S, all the elements appear, and the only ones that are appearing here are 1 and 2. Similarly, G is mapping S to T, and so here G, well, here's more evidence that the set S is just 1 and 2, and the range of G is the set T, consisting of A, B, C, and D. Okay. Finally, H maps T to R, so here's T, and here's R again, and we're already done with R. And it makes sense because R was the set little a, b, c, and you can see it's little a, b, c in this table defining all 18 of those H functions. Okay. Now we're going to do part B. The domain and the range of the function G4 composed with F4. Make a table defining how this function maps elements of its domain to elements of its range. Okay. When we write, so here's part B. When we write G4 composed with F4, what we're doing is we're saying that we apply F first and then G. Okay? Let me try to straighten this out here. And so this function maps the domain of F to the range of G. And the domain of F is R. And the range of G is T. Okay? And so F maps R to S, and then G maps S to T. And we can write R to S, here's F, and here's G, mapping S to T. Okay, and here's F composed with G. Okay, and this happens to be F4 and G4. And we're supposed to make a table for this one. Okay, and so we're going to write G4 composed with F4, and we're going to make a table that takes the elements of the set R, which is A, B, and C, and we're going to write that G4 of F4 of A is G4 of F4 of A, like this. Sorry about my handwriting. And F4 of A is 1, and G4 of 1 is big A. So we're going to have a big A here. Okay, and G4 of F4 of B is equal to, well, F4 of B is 2, and G4 of 2 is capital D. And finally, G4 of F4 of C is, well, F4 of C is 2, and G4 of 2 is big D again. So A, D, D. Okay. For part C, we have to do the same thing. Okay, I'll do C over here. And now I've got H2 of G5. And that maps the domain of G, which is S. And then G maps S to T, and H maps T to R. So we can string them together like this. So this maps S to R. And H2 of G5 maps S to R. And so S is the 1, 2. And H2 of G5 of 1 and H2 of G5 of 2. And G5 of 1 and 2 is B and A, big B and little a, big A, and H2 of big B is little a, and H2 of big A is little a also. So they're both equal to little a. Okay. Similarly, for the next one, F6 composed with H10. F6 composed with H10 maps from the domain of H to the range of F. T to S. Okay? H maps T to R, F maps R to S, so their composition maps T to S. And I'm sorry I have to keep sliding up and down here like this. It's not so convenient. And finally, F6 of H10. The elements of T are capital A, B, C, D. And F6 of H10 of A. Let's see, H10 of A. She's sliding up and down. This is crazy. Is little a. Here I'm showing an extra step. And F6 of little a is 2. And I can similarly use H10 and F6 on A, B, on B, C, and D. I'm just going to do it by looking at it. F6 of H10. H10 maps A to A, B, A, A. Okay? And so F6 of little b is a 1. Okay? And since H10 of big C and big D are both the little a, they map to the same thing that H10 of capital A do. Okay? Well, let me remember here. Little b went to 1. Okay? So this is a 1 and a 2 and a 2. You can fill in the details there. Finally, part E. What is the domain in the range of F6 and H10? Oh shoot, I repeated it here and I forget what I gave you as the new one to do. So I won't do anything there. Which of them are 1-to-1 and onto? Well, let's just solve this problem by marking the tables. And the 1-to-1 functions are the ones where we don't have any repeats. None. Okay, so 1 to 1 to 1. I'm going to mark with a star, and on to I'm going to mark with a plus. Okay. And one-to-one functions means that I don't have any repeats. So star, 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 and star. I have no repeats there. Do I have repeats here? Yes. Okay, so now I'm looking here. Repeats, yes, 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 yes. Since the range is smaller than the domain, I've always got repeats in the H's. Yeah. And since the domain is smaller in the F's, I always have repeats as well. So those are the only ones that are one-to-one. The ones that are on-to capture the entire range. So here we have both the 1 and the 2, both the 1 and the 2, 1 and 2, 1 and 2. And the only ones that aren't have all ones here and all 2s, F1 and F8. Okay, do we have all 4 A, B, C, D in any of these columns? No. By the pigeonhole principle, we can't. There's only 2 places, so we can't have all 4 of them. Well, just I don't know if that's the pigeonhole principle, but we can't have all 4 of A, B, C, D in only 2 spots. Finally, we're looking for all 3 of A, B, and C here, and I see an A, B, and a C. Here's one with all A, B, and C. Here's another one, H6, H8, A, B, and C, H12, H16, H17, and H18. Also H15. So those are the onto functions. We're looking for all 3 A, B, and C in a single column here. Okay. I think I've done all of it then. Which ones are bijections? No bijections. Because we don't have any functions that map a domain to a range where the domain and the range have the same size. Okay, hope that helps.